Yeah. Hi, students. I am Dr. Badrinath, and in this video, we will see the biostatistics concept. One of the important concept that is a correlation. Correlation. By seeing the picture itself, I think you might got what might be the my mind. Okay. Relation is there. Correlation is there. Okay. What is the great correlation is there or relation is there? See, we have all very big family, okay, and we have relatives. Either that relationship is co-relationship is there or not, correlation, cooperation is there or not. In the relation, if is there cooperation between the two persons, then you can say it is a correlation. Okay, if there is no correlation, the families will be simply like that, relations only will be there. But correlations you have to maintain. Okay, see, this film is a national award film, national award winning film in India. It's a national award. All are very correlative. Okay, I can't call them as a relatives. I call them as a correlatives, right? Yeah. See, this is the your statistics subject syllabus. You can see in the biostatistics, it is a common for all courses, all pharmacy courses, B.Pharm, M.Pharm, Pharm.D, PhD. And here you can see linear regression and correlation. This topic we will complete. Correlation, introduction, Pearson's and spearmans correlation. Two are there. One is Pearson's. Pearson, son, keep in your mind. Pearson. Here, spearman, man. Here, man. Here, son. Okay. Correlation and correlation coefficient. That is also very important. Correlation coefficient. Entire topic will complete within a sweet and short. Right. Yeah. The relationship between a two persons in a family should be like a fish and water, but it should not be like a fish and fisherman. That was a great dialogue. Okay. It delivered by the Mohan Babu in the movie of Pedraidu, super duper hit film, right? Like that, you have to maintain the relationship. Okay, very good correlation you can be find between a fish and water. Okay, very bad correlation you can find between the fish and fisherman. Yeah, here you can see the relation between a daughter and father. Just I took example to compare with your concentration versus absorbance. We know very well this is a standard graph, concentration, absorbance. If you are increasing the concentration, absorbance increases in this fashion. Okay. See, first relation is there here. Yes, here relation is there. Here also relation is there. Either it is a correlation, good correlation or bad correlation. See, whatever daughter says, father has to listen. Whatever father has to say, the daughter has to listen. Like that, there must be a good understanding between a daughter. This movie is from Akashamanta. It is a Telugu movie, Trisha and Prakash Raj. Okay, correlation is here. You can see negative, positive correlation and negative correlation. Two types of correlations are there: positive, negative. Now we will see what is that. Yeah, here you can see the three types of correlations are there. One, two, three. All right. First one is positive correlation. See, increasing. Here, x value we know very well. It is a independent variable. Y is the dependent variable. Y is always depends on x, but x doesn't depends on anything. Concentration doesn't depend. Absorbance depends upon the concentration. Concentration, whatever we want, we can be make 5, 6, 10, 8, 9, 10 like that. I will make my own. That's why it is an independent variable. Okay. And in negative correlation, see here, if you are here increasing, here, that's why it is a positive. Here, see, if I am increasing this value, but here decreasing, negative correlation. See here, negative correlation. Here, there is no correlation at all. No relationship. No correlationship. Yeah, correlation, positive direction, increasing fashion. This is a positive and linear. Linear means a straight line. You can see here, straight line, you will get exactly, you can define, you can get the equation also for that curve. Y is equal to mx plus c. Like that, you can develop one standard equation, okay, between the two variables, x, variable x, variable y. Positive correlation, high values of one variable associated with the high values of the other. See, if I am increasing the x-axis values, y value variable, that is where it also increases. When I increase x, y also increases. That you have to keep in your mind. Okay. And this is the correlation negative direction. See, decreasing like this. See, decreasing like that, it is going to down. Okay, negative correlation. The negative sign means that the two variables are inversely related. What father says, mother will not listen. What daughter says, father will not listen. What father says, daughter will not. So, see, variables are inversely related. So the family will become a irreversible. The entire family will be like this. It becomes a inverse. That is, as one variable increases, the other variable decreases. That point you have to keep in your mind. Yeah, here you can see linear means a straight line. I already told. See, here straight line is there, but negative is there. It is a negative linear, like that you can mention. Here, by seeing the here, you can say it is increasing, okay, and also straight line is possible. You can draw, okay. However, some relationship we are able to see here. It is a positive linear. And here you can see non-linear because there is no straight line. It is increasing only. Positive is there, increasing, but the straight line is not possible. Then that's why you can call it as a non-linear. You will get some curve-like structure here, non-linear. Okay. Here, no relationship. We cannot define particularly either it is a positive or negative or see no relation. Nothing is there. Either it is a positive is not there, negative is not there, linear is not there, non-linear is not there. Some more examples we'll see. Linear relationships. See, it is a positive linear. This is a negative linear, but both are the linear. That's why I made a heading here, linear. Here, curvy linear. See, up to certain point it is increasing. Later it is decreasing. So you will get a straight line like this up to here and also down. So up to certain extent it is a positive and up to certain extent it is a negative. Curvy linear you will get somewhat like a just like a up and down. Here you can see it is increased slowly initially. Later up to after this point it is increasing very linearly. See, here also you will get a one straight line here and slope varies here. Two slopes you will get for this curve. Okay, it is called a curvy linear relationship. And you see the strong relationship, very narrow. Perfectly you can define. If it is still narrow, still strong. If it is a only one line, no, all dots are in single line, you can say it is very strong. Here, these are the relationship is there, positive is there. Okay, weak relation, very broad is there, weakly. So it spoils soon if it is like this. Here, linear, negative linear, but it is a strong negative linear. It is a weak relationship is there. Negative. Okay. And here we cannot define perfectly, no relationship. Here straight line we will get like this. Horizontal we will get. Okay, no relationship. Yeah, here you can see the definition. A scatter plot. Scatter plot, only dots, no line. Then you can say it is a scatter. All these are the scatter plots. Scatter diagram is used to show the relationship between the two variables. Correlation analysis is used to measure the strength of the association or linear relationship between the two variables. Then you can say it is a correlation used to analyze the measure, used to measure the strength of the association. How much strength is there in the relationship is called as a correlation. Okay. Yeah, now you see how to measure. This point we know already, relation is there, okay. Correlation is there, either good or bad or positive or negative. And how much correlation is there? Correlation is there. How much? That is the measure. How to measure this correlation? By the correlation coefficient. This is the important word what you have to keep in your mind. Correlation coefficient. How much cooperation is there? Strength of the correlation we are measuring. Degree of correlation we are measuring. It is also, all these are the synonyms. Either full correlation is there, partial correlation is there, nil is there, various types are there. We can measure the correlation coefficient with various parameters that we are going to be measure. Methods are there. That methods we are going to be see. All these methods will measure the correlation coefficient. Correlation coefficient is a numerical measure. We are giving a number here. How much strength is there in your correlationship? Okay, of some type of correlation, meaning a statistical relationship between the two variables. Actually, it is not very easy because two are variable. X-axis is having some variable. This is also, so father is varying and daughter is varying. Okay, she is also variable and father is also variable. And you have to measure what is a correlation. It's not easy. Yeah, here types of correlation coefficients. Pearson's, intra-class, this was there in your syllabus, Pearson. I have already shown now, Pearson and spearmans. Rank correlation, rank, spearmans rank correlation coefficient. Okay, and Kendall, Goodman, Kruskal, Gamma, tetrachoric and polychoric. But all these are there. This list you have to keep in your mind. You write in the examination. Correlation coefficients can be measured by so and so. But Pearson's and Spearman is there in your syllabus. That we will see. Pearson's correlation coefficient, PCC, also referred as a Pearson's R. See this R. Or the Pearson's product movement correlation coefficient, also PPMCC, or bivariate correlation. Okay, is a statistic that measures the linear correlation between the two variables X and Y. See, here we know that population and sample, and we know population, sample. See, when we are comparing Pearson's, when we are comparing two populations, this population we are comparing with this population. Nowhere we are not considering with the sample here. Population, if I am comparing, then Pearson's correlation is called as a rho. Very, very important. Rho is nothing but Pearson's. When we are comparing the two populations, correlating the two populations. Okay, and Pearson's correlation coefficient is called as a R. Here it is a rho, but here we can see R. When we are comparing the sample, two sample correlation between the two samples, when I am comparing, it is called as a R. Yeah, features of rho and R. Maximum here range between the -1 to +1. Too closer to -1, strong negative, -1. Positive 1, strong positive, linear is there. Okay, 0, weaker. Okay, linear relationship. This is the equation. Not much important. Okay, not much. Don't need not to be practice this for exam. Yeah, here you can see this is very important. Correlation coefficient R. See here R is 1. See pakka all dots are on L. So I draw a line also even on the dot. So very good positive correlation is there. Very good cooperation is there. Coefficient, see coefficient is R is equal to 1. Maximum, more than 1 is not possible. 1 is maximum. That's it. Here, see dots are somewhat wider. when compared to this. It is somewhat weak when compared to this. Whereas when compared to this is strong. Okay, 0.8. See here, it is a 0.3, very widely. See, dots are, line is not possible to draw almost. Here, perfectly you can draw. Here, it is a minus. All these are the minus only, negative correlation. Here, minus, pakka line you can draw, but it is a negative, -1. This is a minus 0.8. This is a minus 0.3. All these diagrams you have to write in the examination. R is equal to 1, it's a very good. -1, worst, reverse. R is equal to 0, no correlation, no relation, nothing. This table is very important. Correlation coefficient R 0.8 to 1, very strong positive 0.6 to 0.79 R values, and 0.4 to 0.5 moderately positive, weak positive, very weak positive, very weak negative, moderate negative, strong negative, very strong negative. Relationships. And spearmans rank correlation coefficient, it is also same only, rho R only. Here also, see here, rho R. Okay, no problem. In the exam you can write rho R. Mainly in the graph also, whenever you are drawing a calibration curve and all, we are measuring with R only. Rho nobody was using, because always we are comparing the samples, not the populations. This is the equation for the rho for spearmans. This you can write in the exam, easy. Okay, and this is some points related to Spearman correlation. Okay, that's it. The movie is end. Shatamanam Bhavati. Right? Okay, in my playlist I have kept all my videos that you go and watch.